Existence is akin to a texture like stretchy material similar to a trampoline net. Twist this trampoline net into a pretzel shape and allow yourself to move backward in time. Have you ever wondered what's truly out there in the cosmos? What marvelous mysteries the universe might be concealing from us? Well, you're in for an insight that is utterly groundbreaking, revealed by the renowned American physicist Michio Kaku. A discovery so monumental, it alters everything we thought we understood about the cosmos. Prepare yourself as the James Webb Space Telescope, launched on Christmas Day 2021, unveils transformative insights. This telescope has settled in space, uncovering secrets from the universe's most obscure and distant regions. It's akin to the ultimate time machine, equipped with ultra-powerful infrared instruments ideal for looking into the past. With its unparalleled resolution and sensitivity, it can detect ancient and faint objects that even Hubble couldn't observe. We're talking about distant worlds and celestial bodies from the early universe, those elusive details that have been playing a cosmic game of hide-and-seek. Essentially, James Webb is aiding us in assembling the universe's incredible star puzzle, one infrared image at a time. Imagine yourself in an art gallery, admiring fantastic images captured by the James Webb Space Telescope, JWST. The imagery is breathtaking, with distant galaxies sparkling across the vast fabric. Yet among the astronomers and cosmologists, you see shock and disbelief. There's a sense of conflict, as though they're gazing at a Picasso in a room filled with realists. The common phrase you hear is, "This is astonishing, so what's the fuss about?" What's shaking the very foundation of how they interpret the cosmos. Although the official papers are silent about it, the main issue lies with a theory they cherish, the Big Bang Theory. This theory suggests our universe began in a massive explosion around 14 billion years ago and has been expanding ever since. However, the new images from JWST seem to question its validity, sending shockwaves through the community. You can almost sense Alison Kirkpatrick, a trained astronomer from the University of Kansas, grappling with her work. Why is everyone so astounded? Well, the galaxies captured by the JWST aren't behaving as they should according to the Big Bang Theory. They're too small, too smooth, too old, and there are too many of them. Let's try to simplify it. If you imagine the universe as an expanding balloon, galaxies shouldn't look smaller as they move away from us. After a certain point, they should start appearing larger because their light supposedly left them when they were closer. It's a peculiar but fundamental twist in the expanding universe idea. Yet the images from JWST show galaxies that are about the same size as those near us. It's like expecting distant friends to appear as tiny dots far away, but instead, they're right next to you, plain as day. Curiously, they show galaxies appearing smaller than we'd anticipate, even those that shine brighter and contain more mass than our own Milky Way. Furthermore, these galaxies have significantly higher redshifts, indicating they're apparently moving away from us at faster speeds. This anomaly was pointed out back in 2014 by some scientists analyzing HST images, and JWST seemed to continue this trend. In simpler terms, JWST images show galaxies that seem the same size as those near us, as if the universe isn't expanding and redshift is merely a function of distance. But if we adhere to the theory of the universe's origin and its expanding universe idea, we're left with a perplexing conclusion. These distant galaxies should be incredibly small to compensate for the supposed optical illusion created by an expanding universe. Take, for example, a galaxy named GHC2 that JWST identified, far brighter than the Milky Way but determined to be only 300 light-years in radius compared to the Milky Way's 50,000 light-year span. Its brightness per unit area would be multiple times that of the brightest galaxy in our local universe. Not just that, its density and that of several other new galaxies would be thousands of times higher than the galaxies we see around us today. Now, when you consider these minuscule and smooth galaxies, the concept of an expanding universe, and by extension, the theory of how things came to be, starts to collapse. That's why these findings are causing quite a stir among astronomers and cosmologists. Over the years, Hubble Space Telescope images supported the idea, but JWST photos suggest numerous galaxies dense and strong, similar to powerful mice from old cartoons. These galaxies are an enigmatic puzzle in themselves, and with the new James Webb Space Telescope, things have just become more complicated. To make sense of these curious small galaxies, scholars have advanced a hypothesis. It's as if you're playing with a small toy car, magical despite being only a centimeter long, weighing as much as a real SUV. They propose these miniature galaxies collided over billions of years, merging to form the regular galaxies we see today. It's like toy cars colliding and growing to appear as real SUVs. However, here's the twist. JWST has taken a close look at these galaxies and found no signs of such cosmic collisions. You'd expect these colliding galaxies to show some signs of damage, maybe look mangled or torn, but that's not what we see. Instead, JWST reveals galaxies that are smooth, pristine spirals, just like the ones nearby. There's an absence of cosmic collision marks. One study, aptly named a panic, highlights that there are 10 times more of these pristine spiraling galaxies than scholars had anticipated. This is akin to finding a busy highway with speeding cars but no accidents. This is quite a serious blow for the collision hypothesis. Without signs of cosmic mergers, the idea that these little galaxies somehow evolved into their grander counterparts falls apart. If they didn't grow in size, it means they weren't small to begin with. Hence, the optical illusion we'd expect from an expanding universe doesn't seem to be there. Without this illusion, the concept of expansion loses ground. Hence the growing unease among Big Bang supporters. The presence of these small and smooth galaxies suggests that the universe may not be expanding, and if it isn't, the theory of how things came to be suffers a significant blow. And there's another perspective to consider: the age of stars. The theory of the universe's origin suggests that everything appeared following the Big Bang. However, if these galaxies existed before that, then it would mean the Big Bang didn't happen. This could be a game-changer for how we might interpret the universe's beginnings. Consider the James Webb Space Telescope as a time machine, able to peer billions of years back into the universe, capturing images that shed light on the universe's origins. This stunning device isn't capturing photographs in our familiar visual range, but instead focuses on the infrared, revealing hues of galaxies so far off we would never notice them with our unaided eye. These colors aren't just beautiful. They tell the age of stars in these galaxies. Young, red-hot stars emit a distinctive blue, while their older, cooler counterparts, like our sun, glow in shades of yellow and red. By analyzing these variations, astronomers estimate the age of star populations in these distant galaxies. According to the theory of how things came to be, the galaxies furthest away in JWST images represent a snapshot from around 400 to 500 million years after the universe's birth. However, some of these galaxies seem to house stars that are more than a billion years old. If you've been following the theory of how things came to be, you know that's a big problem because nothing should be older than the Big Bang itself. Another assumption is that as we look farther into space, which means looking further back in time, we should see increasingly fewer galaxies until we reach where there are none, a massive dark age, if you will. However, it seems to be a different story. The new images show that there are at least 10 times more galaxies than expected at high redshifts over z=10. So, the question is, how could so many large galaxies form in such a short time? The answer is, they likely couldn't, simply not under the constraints of the theory of the early universe's origin and its expanding universe idea. And that's why these discoveries are challenging the foundation of our understanding of the universe. On top of that, there's a deeper philosophical quandary: the concept of time itself. Modern physics operates with the understanding that time exists, an essential concept deeply embedded in how we might interpret the universe, intertwined with Einstein's theories of relativity and countless scientific principles. However, what if time as we understand it doesn't actually exist? This hypothesis is revolutionary. It isn't entirely new. Some theoretical physicists have been speculating that time might not be a fundamental aspect of reality, suggesting that our perception of time could be an emergent property or even an illusion. In the context of the universe's origins, this could mean that our understanding of existence unfolding in a sequence, with the Big Bang as the starting point, might be fundamentally flawed. If time doesn't exist in the way we perceive it, then the concept of a beginning like the Big Bang becomes irrelevant. This could fundamentally change how we might interpret the universe, requiring a new framework that doesn't rely on time as a fundamental component. Instead, the universe may be better understood from a perspective that views spacetime as a whole, without a sequential beginning or end. This worldview shift might actually explain some of the perplexing observations made by JWST, like the presence of mature galaxies in what we thought was the early universe. If time isn't a fundamental property, then these galaxies could be older than the Big Bang without violating the laws of physics. Essentially, without the necessity of time, the universe might not have a specific beginning at all, suggesting a more complex and intertwined cosmic tapestry. In this new model, the universe could exist in a state where past, present, and future are not linear but coexist in a manner beyond our current understanding. This would have profound implications for cosmology but also for how we might interpret existence itself, potentially leading to profound discoveries about the nature of reality. The debate between the Big Bang and steady-state theories represents two fundamentally different views on the universe's nature. The Big Bang theory posits a universe with a distinct beginning and a history of continuous expansion. On the other hand, the steady-state theory suggests that the universe has no beginning or end, with an average density and ongoing matter creation to fill in the gaps left by expansion. To summarize, the James Webb Space Telescope isn't just offering a new lens through which we can observe the universe. It's also presenting data that challenges our long-held assumptions about the universe's history. These observations could indicate that the theory of the early universe's origin, as it now stands, isn't entirely accurate. Instead, the universe may be eternal without a specific beginning or end. This doesn't necessarily mean that all our understanding is wrong, but it implies that there are deeper, more complex elements at play which we have yet to fully grasp. It's an interesting time for astronomy and cosmology, as we stand on the verge of potentially momentous discoveries that could reshape how we might interpret the universe. The James Webb Space Telescope, JWST, represents a monumental leap forward in our ability to explore the cosmos. Unlike its predecessor, the Hubble Space Telescope, HST, JWST is optimized for infrared observations, allowing it to peer deeper into space and time than ever before. Its sensitive instruments can detect faint signals from the earliest galaxies, shedding light on the universe's infancy. One of the most intriguing aspects of JWST's discoveries is its observation of ancient galaxies that appear surprisingly mature. These galaxies challenge conventional theories that suggest galaxies should evolve over billions of years through mergers and star formation. Instead, JWST reveals galaxies that seem to have formed much earlier and in a more mature state than expected. This phenomenon raises fundamental questions about the nature of galaxy formation and evolution. If galaxies were already mature billions of years ago, it suggests that our understanding of cosmic evolution may need significant revision. Perhaps galaxies formed more rapidly and efficiently in the early universe than previously thought, driven by unknown processes or conditions. Moreover, JWST's observations of distant galaxies provide clues about the conditions that prevailed in the early universe. By analyzing the composition of galaxies' atmospheres and the light emitted by their stars, astronomers can infer details about the environment in which these galaxies formed. This information helps paint a more complete picture of how the universe evolved from its initial moments to the complex structures we see today. Another groundbreaking aspect of JWST's mission is its ability to study exoplanet atmospheres in unprecedented detail. By analyzing the light that passes through or reflects off these distant worlds, astronomers can identify key molecules such as water, carbon dioxide, and methane. These observations provide insights into the potential habitability of exoplanets and the diversity of planetary systems beyond our solar system. In addition to studying galaxies and exoplanets, JWST is poised to investigate other cosmic mysteries, such as the nature of dark matter and dark energy. These elusive substances make up the vast majority of the universe's mass-energy content but remain largely invisible and poorly understood. JWST's sensitive instruments may provide clues about their properties and distribution, offering new insights into the underlying structure of the cosmos. Furthermore, JWST observations have the potential to refine our understanding of fundamental physics, including theories of gravity and the behavior of matter under extreme conditions. By studying phenomena such as gravitational lensing and the gravitational interactions of galaxy clusters, Astronomers can test predictions made by Einstein's theory of general relativity and explore alternative theories of gravity. Beyond its scientific discoveries, JWST represents a triumph of international collaboration and technological innovation. It involved contributions from NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA), as well as numerous academic and industrial partners. The telescope's development pushed the boundaries of engineering and material science, requiring groundbreaking advances in mirror technology, cryogenics, and spacecraft design. Looking ahead, JWST promises to revolutionize our understanding of the universe and inspire future generations of scientists and explorers. Its discoveries will shape the course of astrophysics for decades to come, revealing new insights into the origins of galaxies, stars, and planets, and offering a deeper understanding of our place in the cosmos. As JWST continues its mission, astronomers eagerly await new data and insights that will further expand our knowledge of the universe's evolution. Each image and spectrum captured by JWST represents a glimpse into the distant past, providing a window into the cosmic history that shaped our present-day universe. In conclusion, the James Webb Space Telescope stands as a testament to human ingenuity and curiosity, pushing the boundaries of what is possible in space exploration.